Hello everyone, this is Professor Lee again. Today we are going to talk about what's called binomial distribution. Binomial distribution. Now this chapter 4.3, we're going to cut it into two parts. And today we are going to discuss part A, right? Binomial distribution. So binomial distribution, what's bi means, right? Bi means two. So we are considering a distribution case, a probability distribution case that has possibly two possible outcome or two possible result. So we are dealing with a two possible result case. That we are going to discuss in this chapter. So let's start with this example. Let's say you are on a TV game show called Wheel of Fortune. So you get to spin the wheel, and if you happen to land it on the gold, then you are going to get a $50,000 for your prize. So you get to spin the wheel, and if your wheel landed on a gold spot, then you are going to get $50,000. And I guess if you do not land it on gold, then you really do not get anything. Now, in the roulette wheel, there are 36 slots and only one of them, which is gold. So, if you spin the wheel once, what would be the probability that you are actually landing on the gold? Well, it's going to be 1 out of 36, isn't it? Because there's only one slot out of 36, which is the gold. So if you want to say the probability of getting the gold and getting the $50,000 as a prize, when you spin the wheel once, it's going to be 1 out of 36, just like that. Well, that's not that difficult to figure out, right? But that's not the main question here, right? That's not the main question here. The main question here goes like this. Let's say 100 people lined up to spin the wheel, right? There are 100 people get to spin the wheel. And what would be the probability? What's the probability that out of those 100 people, exactly 3 of them will actually land on the gold and get this prize? Now that's the question here. So the question that we are asking here is that not you spin the wheel once and what's the chance that you are going to get the gold? That's this probability right here. That's easy compared to this question right here. But the main question here is that 100 people are lined up to spin the wheel once, then each of them will get to spin the wheel once. Now, out of those 100 spin, what's the probability that exactly 3 of them will actually land on the gold and get the prize? Now, that's a typical binomial experiment probability question, right? That's a typical binomial probability experiment question. Now, so what's the answer and how do you find the answer? Well, you have to wait a little bit to see the actual answer, right? We are going to talk about the actual answer later on though. Okay, so this binomial experiment, or it's called Bernoulli experiment, is actually studied and researched by a Swiss mathematician, Jacob Bernoulli, in late 1600s. So, we are looking at like, 400, 300 years old mathematics here, right? Okay, so to be classified as binomial experiment, we need to satisfy these five conditions. So if these 5 conditions satisfy, then we can go ahead and consider that case as a binomial experiment case. So, I mean, what if it is a binomial case? Then what? Then we get to apply this whole situation into this formula so we can figure out the actual answer, right? So that's coming on. But let's see the basic features, characteristic of binomial experiment. Now, first one, it has to be fixed number of trial. Now, in our Wheel of Fortune case, fixed number of trial means you don't get to spin the wheel forever. You get to spin the wheel a fixed number of times. Now, in our case, we are spinning the wheel 100 times. So that's going to be the fixed number. And the fixed number of trial is denoted by letter N. So in our previous case, N is going to be 100, like that. And those N trial must be independent, meaning they don't interfere with each other, right? We talked about this independent and dependent before. So they don't interfere with each other, meaning just because my previous person landed on the gold, that's not going to affect my probability of landing on the goal in my spin, right? Each spin a separate spin, so they don't interfere with each other. That's being independent, right? Which is our case. So we get the green light for this second condition too. Now, each trial, in our case, each spin only has 2 outcomes, either success, denote as S, or failure, denote as F. Now, only each spin, each trial in our case, has 2 possible outcomes. For us, we either landed on the goal or we do not land on the goal. So that's the 2 cases, right? So it doesn't have to be like, coin flip that you obviously have head or tail 2 choice. Even if the slot has 36 choice, meaning you have 36 possibility. For you, you only care whether you landed on the gold or you do not land on the gold. That makes this as a 2 outcome case, which is success or failure case, right? So it satisfies our Wheel of Fortune case as well. Now, for each individual trial, probability of success is going to be the same, and we are going to assign value P for probability of success, and variable Q for probability of failure. So each spin, what was the probability of success? Well, there's only 1 slot out of 36. So in our case, our P was 1 out of 36. Well, if this is a probability of success, what do you think the probability of failure then? Well, probability of failure, as you can see, when you add the probability of success and probability of failure, it should add up to 1. So 1 minus of P would be the probability of failure. So it's going to be 35 out of 36. That's going to be the probability of failure. So when you add this, it should add up to 1, right? See that denominator are the same. So you only need to add the top. That's going to be 36, right? So 36 out of 36, which is 1. And it's not that difficult to figure out the probability of failure. For example, let's say probability of success is 0.25, 25%. What do you think the probability of failure is going to be, right? If you have 25% chance of success and failure chance is going to be 75%, just like that. So when you add these two, it should add up to 1. right? Just like that. So if you know one of them, figuring out the other is not that difficult. Now, look at this condition number 5. It says, central problem of binomial experiment is to find the probability R number of success out of n trial. Sometimes they use R, sometimes they use X. X number of success out of n number of trial. That's going to be the central problem of this binomial experiment. What do you mean by that? Well, let's go back to this Wheel of Fortune case. We are not interested in figuring out the probability of one success. That's just a part of the question, but the main question is right here. When we spin the wheel 100 times, what's the chance that exactly 3 of them is going to be landed on the goal? That's the main part of the question, right? So as I was saying, the main part of the question is that exactly X equal 3 out of how many trial? N equal 100 trial. That's the main part of the question. And that's what they're saying in this condition. R, they use R, but they also use X. I think they use X more than R. So X number of success out of N trial, that's going to be the main part of this question. And that's what we call binomial probability experiment. Okay, so, we were saying independent trial, that's our first criteria, right? Fixed number of trial, that's the first criteria. So we have exactly 100 trial. So in that case, N equal 100. And each trials are independent trials, which means, the previous result is not going to affect my current result, right? Which is the case for us. And only 2 outcomes, right? You landed on the gold or you do not land it on the gold, right? 2 outcomes. And probability of success that we are going to say P, and probability, which is in our case 1 out of 36. So consequently, the probability of the failure, which is going to be Q, is going to be 1 minus 1 out of 36. So it's going to be 35 out of 36, right? You know how to do this, right? You change this 1 as 36 out of 36 minus 1 over 36, right? So this is going to be 36 and 36 minus 1. That's how you get this, right? And it's not, again, it's not that difficult when you know that P is going to be 1 out of 36. Then Q is going to be 35 out of 36, just like that, right? It's not that difficult to figure the other part like this. Again, the main part of the question that you are looking for X number of success out of N trial, right? So it could be R, it could be X number of contestant out of 100 trial, right? Just like that. Okay. So again, main part of the question, we are looking for X number of success out of N trial. That's going to be the main question for this binomial probability distribution, right? Binomial probability distribution. All right. So X number of success out of N trial, we can also figure out if it's a binomial distribution case, we can also figure out the mean, we can also figure out the variance, and we can also figure out the standard deviation, right? Okay. Okay, as I was saying, we can figure out the mu, which is the mean. We can figure out the variance, which is sigma square, and we can also figure out the standard deviation, which is the sigma. So let me recap a little bit. So we are saying that if this is a binomial distribution case, we can figure out the mean and variance and standard deviation of that binomial probability distribution with a very simple formula. And these are the formulas right here, right? These are the formulas. So how do you figure out the mean, the mu? Well, n, what was n? Total number of trial. What's p? Probability of success. So all you need to do is just n times p, and that's going to be the mu, right? So I think this formula is very simple. To figure out the variance, it's also very simple. N times P times Q. So N, again, is the total number of trials. P is probability of success. What about Q? Q is probability of failure. So if you just simply multiply those three, and you can get that variance. And once you get the variance, then you can also get the standard deviation just by taking the square root of whatever the result that you have here. And that's the standard deviation right there. So figuring out the mean, variance, and standard deviation in binomial distribution is very simple in a way, right? Once you get the N and the P and the Q figured out, it's just a matter of putting it in the calculator. Now, what about the actual case? Actual answer for what? Answer for this right here. Finding the probability of X number of success out of N number of trial. How do you actually figure out the answer? Well, you are going to use something like this formula, which looks kind of scary, right? It looks kind of scary. So, well, let's dissect a little bit. See this part right here? NCX, that is called combination. That is called combination. So how do you actually figure this out? So if you look at this formula and this formula, now what do you see in common? See this part right here? P to the x power q to the n minus x power is exactly same as in here, which means this NCX part, that part right here, that is, if I rewrite it here, NCX is n factorial. See that exclamation mark that we read this as factorial in mathematics, and n minus x factorial and x factorial. That's what we call the combination, NCX. So what is that? What is this factorial thing? I mean, factorial is explained it right here. So let me get rid of this part right here. All right. Okay. So let me rewrite it. X factorial. So this n factorial, and how do you calculate that? Well, you start with whatever this number, and you're going down by 1 until you hit 1. So for example, if you have 5 factorial, then how do you do that? Well, you start with the 5, and then you're going down by 1. So 5 times, 4 times, 3 times, 2 times 1. So if you multiply all that, 120 is your answer, right? So that's this combination and factorial that you are dealing with, right? Now, I guess the bad news is that there's a lot of calculation, and good news is that, in fact, we can do this with the built-in calculator functions, right? We can do the whole thing in calculator built-in function. So we are also going to learn how to use calculator for this binomial probability distribution case in our next lecture, right? So this is the actual formula to figure out what? Figure out this probability question. What kind of probability question? Binomial distribution probability question. So how do I know a certain question is a binomial distribution problem? Well, we need to know those 5, let me go back, those 5 features right here. If any question fit into these 5 features, then it's going to be binomial probability question. But even then, there's a lot of things. So is there any one thing that we really have to remember? Well, the one thing that you really have to remember is in red right here. It says what? The central problem of this binomial experiment is to find probability of X success out of N trial case. Then highly likely that it's going to be binomial probability question, right? Binomial probability question. So remember that in our Wheel of Fortune example, if I go back to the original example right here, this is just the explanation what's going on. But where's the actual question? It says, what is the probability that 3 contestants will land it on the gold when there's a 100 people waiting to spin the wheel? So X number of success out of N number of trial. So this question fits into the binomial probability experiment, and we went through each categories, right, of features right here, right, just right here. So that question fits into the binomial probability question. Then how do we actually answer that question? Well, we answer that question using this formula right here. This formula rather looks complicated, and in fact, if I just delete all this, in fact, what we really need to remember at the end, or at least know where to find, is this formula right here, right here. And how do you deal with this n factorial? Well, just like this. You start with this number n, and you go down by 1 all the way until you get the 1 right there, right? Okay, so let's go back to this game show question, TV game show, Wheel of Fortune, and try to figure out this actual answer. So we know that n would be the total number of trial, which is 100 right here. How many success case? are we looking for? So X is going to be 3, just like that. Now we know that P is probability of success. So it says there are 36 slots and only one of them are gold. So P is going to be 1 out of 36. And it says it right here. If this is the probability of success and this is the Q, probability of failure, just like that. Now, remember that, that formula right here. Do we know N? Yes, we know N, that's 100. Do we know X? Yes, it's 3. Do we know P? Yes, we know P right there. Do we know Q? Yes, we do know Q, right? Because it's 35 out of 36. So if we substitute this in here, right? All these variable in here. Now let's replace this N with 100 right there. And N minus X, so N 100 minus 3 times 3, X is 3 right there. And this P was what? 1 out of 36. And what's X? Again, is 3. What about Q? 35 out of 36. So N 100 minus X3. Just like this. So let me pause for a while. So you just go, just check yourself. See if all those variables that we replaced in that formula. Just like that. Okay. Right? You replace that N, the X, and the P, and the Q. Just like that. Now, then this part right here, 100 minus 3, that's going to be 93, just like this. So let me actually pull this part in here. So 100 factorial, if we go back to that factorial thing, the way to figure out the factorial is this, right? N factorial, start with the number n, you go down by 1, you keep multiplying, all the way you hit 1. So, 100, that's a big number. But let's say if we do this part, that would be 100 times 99 times 98 times 97 times 96 times 95 times. And I'm going to skip the bunch of stuff in the middle, 3 times 2 times 1, right? All multiplied on the top part. That's this 100 factorial. What about in the bottom? This is what? 97 factorial. So started in what? 97, 96, 95, all the way up to 3, 2, 1. So let me change. Well, then you have 3 factorial. So 3 factorial is what? 3 times 2 times 1. So let me change the color here. So that's 100 factorial. From here to here is 97 factorial. This is 3 factorial. And that's this part right there. So anything cancel top and the bottom? Yeah, you bet a lot of things will cancel because 97 and down. All this cancels with 97 all the way down to here, right? So in fact, the top part is 100 times 99 times 98. What about in the bottom? Only this survived, right? 3 times 2 times 1. Only that survived. So, if you type it in your calculator, let's say 100 times 99 times 98, and top part, if I just type it in, 970200, divide, this would be 6, right? 3 times 2 times 1. So divide that by 6, enter. Then I get, for that part, 161700. That's a big number, but that's basically this first part right there, right? That's basically that first part right there. So what about the other part? How do we actually type this in the calculator? Well, let me show you how to put this second part in a calculator, right? So let me change the screen. Okay, so I changed the screen here. As we discussed before, let me go to annotate. Annotate. Okay, so this part right here that we got, as you can see from this calculation right here, this would be 161700. So to that, multiply. So, let me retype that though, just to be clear. Oops, okay. 161700 times. So I'm doing this first part. So open parentheses, 1 divide by 36 and close it. That power 3, that you use this button for power 3. And then I move the cursor to put the second part. So again, open up 35, divide 36, close it, power, that's going to be 100 minus 3. I mean, I could have just put down 97 if I want to, right? And then enter. So answer is right here, 0.2254. So I cut it right here, keeping 3 decimal places. Then it's going to be 0.225. So it's going to be 22.5%. So what does that really mean? That really means this. We have 22.5% chance that if 100 people spin the wheel, exactly 3 of them will land it on the gold and take the money, right? If 100 people spin the wheel, what's the probability that 3 of them will land it on the gold and take the money? Well, if 100 people spin the wheel, the chances that exactly 3 of them will land it on the goal is 22.5%. And that's how we calculate this binomial probability, right? Okay, let's go to this next one, right? Let's go to this next one. So let's clear all the thing. Let me readjust it a little bit, right? Just to make it a little bit bigger. Okay, so let's say 32%. This is another very typical type of binomial probability distribution case. 32% of students in a particular community volunteer program outside of school. So 32% students participate in the community volunteer program outside of school. If 30 students are selected at random, that means what equal to 30? N number of trial is equal to 30. I mean, it's right here. Find the probability that out of N student, exactly 14 of them. So this 14 is going to be a probability of, the number of success case. X is going to be 14. Exactly 14 of them will participate community volunteer program outside the school. Then what's the probability of success then? Well, it is given right here, right? That's going to be 32% right there. And then what about Q? Q is going to be 1 minus of P, right? Q was 1 minus of P. So Q is going to be 38%, just like that. Now, all we need to do now is put it in that formula, or namely this formula right there, and get our answer, just like this. So let me show you how I do this in the calculator. Even this, I can actually use calculator to do this. Remember that is this right here, right? So technically speaking, that part is 30C14, right? 30C14. So let me show you how we can do this in the calculator. Let me clear this one up. First, I put 30, right? And then go to math and move your cursor to probability right here. Now, in fact, you have this NCR, right? They use R, they use X sometimes. Even you have this factorial sign there too, right? But since we have this number 3, I'm going to hit this. So that means N, they recognize that as 30. Now, what do I want to put it? 14. I want to put 14 now, and then hit enter. And that number right there, that's a huge number. That's the number that we got for this first part. See that first part right there? That's a 30C14 right here. And that's the part right here, which is the same thing as this. So this part right here is going to be 145,422,675. Now to that number, I need to do this, right? So I can even do this continuously, right? So I can do like multiply. That means whatever the previous answer that I have, then I'm multiplying. So now I'm going to do 0.32 to the power of what? 14. And then I'm going to move this cursor so it's coming down to the actual number, not on the exponent. 0.68 power 30 minus 14 and enter. And that's our answer right there, right? So if we cut it right here, that 8 will change that to 6. And that's how we get this 0.036, just like that, right? So, if they leave it like that, that's fine. If they want that to be in percent, you can put it in percent, right? If they want that to be in percent, you could say this would be 3.6%, right? Because changing this decimal to percent, you gotta push this 1 and 2 times and put the point right there, right? So it could be in decimal like that, or it could be in percent like this. And that's how we put this binomial case into a formula, and from formula, use calculator, get the answer, and just like this. All right, so that's the wrap for this lecture. Right, so let me